Today we're going to be presenting on roadway departure crashes in Montana. We have 3 items. The first being kind of the background or information on the roadway departures. Also looking at the strategic national and Montana strategic plans to address those crashes. And then thirdly, looking at the analytical framework that in SIMS to help us. Roadway departure is the leading cause of fatalities and serious injuries on roadways nationally, and as well as Montana. In 2014, there were nearly 18,000 fatalities from roadway departure crashes. That was 54% of all traffic fatalities in the United States. In Montana, it's considerably higher. That percentage is nearly 64%, and that's based on a 5-year average. In looking at this bar graph, as you can see, roadway departures over even a 10-year period are significantly higher than what we see on the with other types of crashes, including behavioral-based and other roadway characteristics. In Montana, we see about 200 fatalities a year. It kind of goes up and down from there. There was a sudden increase that we saw in 2013. We were on a downhill trend from about 2007. That little spike that we had in 2013 also was on a national average as well, where they saw a spike. As far as roadway departure crashes, which are in the maroon color, we had a little spike in 2012, and it's slowly declining from there, and we'd like to keep going that direction. In Montana, we define roadway departure crashes as fixed object, head-on, rollover, and sideswipe opposite direction. From this graph, you can see that the rollover is our main problem. It's significantly higher than the other 3 combined. In looking at the 4 types of collision types and breaking those out as far as their percentages, rollovers in Montana are nearly 59%, which is nearly 3 times the average on a national level. One of the things that may be contributing to this is we have a rural, very rural state. We have 1 million people. We do have a lot of tourism that does come in, though, with Glacier National Park and Yellowstone. We do have a lot of what we call secondary roads. They do not receive a lot of funding. They have a minimal amount of funding on a yearly basis. We're probably only improving 50 miles of those across our entire state based on the way the current funding is set up. We have set up a task force, and they're meeting this fall, trying to come up with some strategies to present to our legislature. We have a legislature that only meets 4 months every 2 years, so they're gearing up for that session in January to try to find a funding source from the state side to help with that. Some of the things that we see on these secondary roads is they're in remote areas. They were designed for 35 miles an hour, 55 miles an hour. We have a posted speed limit of 70 miles an hour, and all we can do from MDT's side is put up advisory signs on those curves. We don't have the ability to change the speed limit when realistically, as a driver myself, I would never take them at 70 miles an hour. So that's a big challenge. They're also in tight canyons. They're a lot of the connector roads into our towns. So a lot of people have moved outside of town. That's their main route into town and home every night. So you have a lot of traffic on very minimal standards, tight radii, steep slopes, old type of guardrail, some of the old cable rail from the 50s and the 60s, other areas that have no cable rail or a lot of tree collisions. So those are big contributing factors to our roadway departure crashes. And the last thing that contributes to it is the emergency response. It can be close to an hour sometimes before you have any emergency vehicle at the site of a crash, and so that can contribute. I'm trying to think. There's a twilight zone of where that window of surviving it decreases dramatically if you can't get emergency vehicles there. In developing a roadway departure framework, we went with a bottom-up approach. We started with the Federal Highways Strategic Plan. We used that as a guide. Montana then has developed our Comprehensive Highway Safety Plan using that. We've come up with emphasis areas, and from that we are we have developed an analytical framework in SIMS using the safety analyst system. In regards to the Federal Highways Strategic Plan, it's a living document that primarily serves as a tool to provide long-term focus for roadway departure teams' efforts through data analysis. Their 4 areas of emphasis are overturn and rollover crashes, opposite direction crashes, which include the head-on and sideswipe opposite direction, and thirdly, the roadside trees and shrubs crashes, which in Montana we code that in our reports as fixed object. Some of the strategies that the federal government has, or the Federal Highway has noted here. On the overturn strategies, we use curve delineation, enhanced curve delineation. We are starting to use friction treatments and curves. That's not something we've used a lot of in the past, but we are starting to look at a couple curves this year. Shoulder rumble strips have been part of our overall goal as an agency for the last 10 to 15 years. So as any new road is built, if it meets certain parameters, we are installing those shoulder rumble strips. The safety edge, we have a method and design that's been taking very similar to the safety edge, so we have that in place. And the others as well as we address. On the opposite direction crashes, we just recently bid a huge, close to 1,000 miles of centerline rumble strips around our Billings district. Those are currently under construction. In one of our other districts, they're already done with those. So that's been a huge effort of ours to address head-on and sideswipe opposite direction crashes. In regards to the trees and the shrub crashes, the shoulder rumble strips, the delineation, the friction in the curves are all ones that we have been instigating. We do try to clear outside the clear zone rather than put in fixed object if we can avoid that. And fixed object being guardrail and those type of things, that's our last resort. In developing our Montana Comprehensive Highway Safety Plan, we recently updated that in May of 2015. We did utilize SIMS to update that, and so it's and we anticipate that as we go along. In regards to our planning process, reviewing the data is a major element of that, and as we develop our emphasis areas for each update, we anticipate going back continually and having SIMS help us develop that in 4 or 5 years when we revisit the safety plan. As far as some of the behavioral and environmental factors that we see in Montana, you have about half that are behavioral, half that we may have a possibility of addressing with engineering solutions, such as the horizontal curves, adverse lighting, adverse road conditions. So from the engineering side, we will focus on that, and the planning division of our agency will focus on the behavioral type issues. In developing our strategies, we narrowed it down to 5. The first one is based on an analytical framework. It's reducing and mitigating crashes through data-driven proven identification. As far as our engineering solution, we're reducing and mitigating speed-related roadway departure and intersection crashes. That will be our strategy. The other 3 fall more under the enforcement, the media campaigning, and the education. And those include reducing the crashes through education, exploring and implementing best practices, such as related to distracted driving, fatigue driving, and other behavioral issues. And the third one, working with law enforcement to improve the prosecution and adjudication for all roadway users violations. In regards to the analytical framework, where we are in those initiatives is the first one we developed safety performance functions that are specific to Montana. We hired that as a consultant, completed that work for us. We then incorporated that in with our new SIMS system, which is helping us develop the highway safety improvement plan as it highway safety, the HSIP, or the CHSIP. It's helping us develop that on a continual basis. It's helping us identify issues on the network as a whole. And also it's helping us compose countermeasures and complete the benefit cost process. In regards to engineering solutions, we're looking at the two short-term and long-term options. Short-term being based on service life of the improvement. So that's more like rumble strips, delineation, and signing. And the long-term solutions being shoulder widening, slope flattening, and curve reconstruction. The third thing that we've been doing from the engineering side is a media campaign that's focused on roadway departure crashes. We do have the media campaign that goes on in our planning department, which focuses on the drinking and driving, impaired, distracted driving. However, ours focused from the standpoint of what are your consequences if you go out of your lane or run off the road. And so it's much more of a scare factor is how it's presented. It's focused toward 20 to 29-year-old males who have the highest crash rate in our state, and is also an age bracket that has potential to change their behavior. And that's a campaign that's ongoing. We're wrapping it up in 2017. We got an extension with the Federal Highway to finish it up, and it will wrap up in 2017. I did include the video here. Oh, sorry. And I'll try to link into it. Do I need to bring up? Oh, there it is, okay.
Presentation, maybe. This one?
Yep.
All right, what's up, everybody? Myth Crashers is back at it again. We're here in downtown Missoula enjoying this lovely summer evening. Today, we are going to crash one of the sneakiest myths on Montana roads, the "but it only takes a second" myth. If you're driving 70 miles per hour, in 1 second, you'll go
102.67 feet, and a lot can happen in that distance.
In fact, more people die on Montana roads because their car leaves their lane than in any other type of crash. It's a serious deal. We're gonna ask some people here on the street to help us out by doing some simple tasks while they're driving, and we'll see, how long it takes them. Beep, beep. Got a 200-foot tape, gonna make some marks. Whew. It's a long way, man. Excuse me.
Yeah.
Hey, do you think you have a moment you could help us out with something here? Would you be willing to help us out with a safe driving video real quick?
Sure.
Hey, man. Hey, do you have a minute to help us out, you think? We're trying to envision 0 deaths and 0 serious injuries on Montana roads. So
All right.
why don't we set the first down right here? Have a seat in our sweet classic car. He brought his own steering wheel. I should have thought. Okay. Gotta make sure you keep your hands on the wheel. Now we're gonna pretend like you're driving at 70 miles per hour, all right? Pull the phone out and pick out your favorite Blue October song. And I'm guessing you text on that phone sometimes?
Yeah.
Right on. And I'm gonna see how long you look down.
All right.
3, 2, 1, go. Look at the road, you gotta look at the road. All right, doesn't count. You gotta take the wrapper off. In your lap. Oh, that was good and quick.
Yeah,
Only a
not
second.
bad, not bad.
4.13 seconds was how long you looked down. Wow. I'm gonna take this from you because honestly I don't feel comfortable with it in your hands anymore. This might surprise you a little bit.
It might, we'll
It
see.
surprised me. So you went look down for 1.6 seconds. So if you multiply that out, you get 164.192 feet.
Okay.
How far would you guess that is down this alleyway? 233.97 feet. Come with me, we're gonna show you what that looks like. So a half a second gets you about 51.31 feet if you're going 70 miles per hour. Half a second at 70 miles per hour. 1 full second.
Wow.
87 feet. Well, you did that about 12 times.
That's the ways.
That's how far your car traveled while you were looking down. But don't forget, You looked down 8 times. What do you think?
I don't think I should text and drive anymore.
So, what do you think? Whoa, I know. A lot of people don't realize it, but the leading cause of death on Montana roads is people leaving their lanes. And a lot of times it's happening, believe it or not, in nice weather like this. You're just cruising, everything's all good, only takes a second. It's crazy when you actually see how far that is. Tell your friends and your family, and let's keep Montana roads safe, yeah?
All right.
All right, thanks for your help.
Yeah, no problem.
Thank you. Safe driving.
Thank you.
Thank you. Well, I think it's safe to say that we successfully crashed the myth that it's all right to multitask in your car. Our little study over there proves that you cover some serious blacktop when you're not paying attention to the road, even if it's just for a second. That can lead to veering, swerving, being surprised by deer or other drivers, and ultimately a crash. So please, keep this video in mind, share it with your friends, share it with your family, spread the word, and help us reach Vision Zero. That's 0 deaths and 0 serious injuries on Montana roads. I know we can do it, and we can do it with your help. Until next time, we're the Myth Crashers. Keep it between the mustard and the mayo.
And with that, that wraps up my segment, and I'd like to introduce Shaful, who will discuss the analytical framework.
Thanks, everyone. So I would like to go over the analytical framework in SIEMS. So you all know that SIEMS is actually a safety analyst solution that we implemented for Montana. And there are some nice features in this system that actually can help Montana to and Tricia already mentioned about that. Like it can run the analysis and identify the locations. You can actually go to the crash data and do some filter and can help to get some decisions. Like a decision can lead you to update your CHSP plan or any other policy or prevention technique that you are trying to implement. So with that, I would like to show you the first thing is how we are envisioning that this analytical framework will work. So basically, it has 3 components in Montana solution. We have a crash data-driven analysis. So anyone can go to the crash data table and can run a bunch of query. But the query needs to be methodological. I mean, you need to know what you are querying for, because crash itself has hundreds of records and hundreds of variables. So you need to know what you are querying for to get to the point that can lead you to some kind of decision. Then you also have some kind of structure framework, which is network screening and hotspot identification, the second one. And you also have the third one, the proactive screening, that one. So everything that you're running here, either you are running a crash data-driven analysis or a network screening, you are eventually leading to creating projects and doing some benefit and cost analysis on the projects. So basically, that is the ultimate goal for all of the analysis that you are doing. One thing I'd like to mention that if you look at on the right side, there is a federal highway systemic screening process. So the framework that we have is kind of fulfilling that's the same process that federal highway recommended. It has 3 elements by the federal highway process. It has 1 element which is more like a systemic screening process. It starts with identifying the crash type and risk factor. It has screening and project screening and prioritizing the candidate location. Then have selection of the countermeasures and prioritize the projects. Then we have element 2, which is basically identify the funding. And we all know that for roadway departure crash, if Montana has some kind of funding, like if you are getting the HSIP funding, or if you have your any program that you are trying to implement, that will be in the second category to identify the funding, and it can lead you to the decision making. And the third thing we have is the systematic program evaluation, which is whenever you are doing any program, any HSIP projects, the basic idea is you go back and look at your results. Maybe your implementation phase can be like 5 to 10 years, but after that you can go back and see and make sure that whatever you put together in the field is actually working as you expected. And you can always go back and update your safety performance function, or you can update your crash reduction factor based on the results. So that is something in the element 3. Now I would like to show you in the first element how this is happening, which is in the crash data-driven framework. It's starting from querying or reporting the crash data. So anyone in this, whoever is using the system can query the crash data and can get very valuable information from the crash data. I'm just showing you some examples. If you look at on the right-hand side, one thing you already know that I mentioned in my previous slide that Montana, each of the crash record, if for Montana crash, for example, for the Montana crash database, it has more than hundreds of variables. So you need to know how to scientifically use those variables to query what you're looking for. For example, suppose you're going to look for the crash, rollover crash. So one thing you notice that in your crash data, you have a category which is collision type, and the collision type can be rollover or can be fixed object, and there are certain other categories. So your first filter will be, you set the filter for rollover crash, and then the second question is, okay, I identify the rollover crash. Now I'd like to see what are the conditions that is contributing to that type of crash. Is that steep roadway? There's a steep grade on the roadway, or there's some curvature issues going on. So your next criteria will be to run a query on your grade, and the grade is a highway grade or the curvature. So you establish your second filter, and the third category could be if you know your grade is level or rolling or mountainous, and suppose most of the crashes happening on the level terrain, then you need to know, okay, there is steep curvature or steep roadway is probably not the factor. Then you have to look for the second, the fourth tier of this one, which is the behavioral factors. And here we're considering, okay, you can look into the person data and can see if you have some other indications there. And I know for the crash database, we have started capturing the cell phone use or the distraction. So if you can go at that level up to using the person data, you can identify whether that the crash that is happening due to diverse distraction or not. So the idea is whenever you are using a crash data, you have to use some scientific method to actually use the data and to filter the data so it can give you some valuable information. Okay, now let's move on to the next one, which is how the behavioral pattern can be identified. One of the example I have here, you can see what the example I'm showing here. You just query the crash data and you map the crash data on the map. So what you can see that just by visualizing the crash on the map, I was able to identify two locations. There are high concentration of crash. You can see there's one location here. It looks like there is some reverse curvature, which is might be one of the reasons for the rollover crash. So there are two locations I identified. And then you can always get help from the Google and see what is there. For example, I look at that specific hotspot and I zoom into using the satellite image, and I found that this is a US 12, which is west part of Helena. And I found that this is a steep curvature, and I found there's some warning sign also for the trucks, and there is a reduced speed limit. But I also found that there is a guardrail there. So we are trying to put together all these engineering treatments here to make sure that the location is safe. So if you are satisfied with your engineering solution here, then you need to find out whether there is any behavioral reason. So you can look down to the next level, which is search for the behavioral pattern and find out if there is any other cause that is responsible for that. This can also lead you to some other decision making. For example, now the example I'm showing you that suppose you found there are issues with the behavior, which is one of the issue could be the cell phone use, and you're trying to put some cell phone restriction ban for certain cities in Montana. So you do a crash query and you found that, okay, these are the top 5 cities where there are a lot of cell phone use, and Billings, Bozeman, for example, the top 2. But if you look at this data, you have on the left-hand side, you have the total number of crash due to cell phone. On the right-hand side, you have the percentage of the crash. So you can see Bozeman, Billings roughly is the 5%, Bozeman is 4%. If you add these top 5, it will probably get like 25%. Okay, and then if the rest of the cities maybe around like 10%. So you try to mitigate something, and then you found, okay, probably it's not the cities that is responsible for that. It's probably is all over spread all over in Montana. Then what you can do the secondary analysis that I can see it's distracted by cell phone, rural versus urban trend, and you can see that in general you have more in rural areas. There are more crashes due to cell phone use than in the urban area. But if you look at the trend, like the trend is showing that the urban area, there are a growing trend of using cell phone, and there is and virtually like in 2010 it was like only 25 crash versus 100 crash. Back in 2014, almost 100 crash for each cases. So although you may consider that, okay, for cities this is right now it's small percentage, but there is a growing trend of using more and more cell phone at the city level. So it may not be right now in 2015-16, maybe in next 5 years you might need to consider some cell phone banning zone in some of your metropolitan areas. So that this is how we can analyze the crash record and come up with some kind of decisions, policy decisions, or we can update our vision or goal. How many minutes? 9? Okay, that's good. So the next one is more like a structured framework, and I have Tricia already have covered that in her presentation, that the structured hotspot identification technique. This is your next body. Like if you do not get the answer from your crash record, then you have to do a more structured framework. You run the network screening and identify the hotspot. And in this framework, if you look at on the left-hand side, the first thing we do is establish crash filter for the network screening. So from your crash data, when you're running the query, that is more like an unstructured crash filter. Basically, you're looking at the crash data, you're trying to do the mining of the data and try to find out some reason behind the rollover crash. Here we are doing a more structured way. We have a setup table for crash filter, and you can establish those filter and can use that when you're running the network screening. And that's what Montana is doing right now. They have established, I think, more than 100 different filters. And when they're running the network screen, they can call any of the filter, run the screening, and it will only identify those crashes under that categories. So suppose you can run a filter for the road departure crash, run a screening, and it will identify the hotspot with that rollover crash only. If you identify like alcohol-related crash and run a screening with using that, it will identify the hotspot of the location that is only related to the more alcohol use. So that is a more structured way you can run the analysis. One thing is I'd like to mention about Montana that is a very good thing for them, that they have established their own SPF, safety performance function for rollover crash. And this is a good example I have not seen in other states, that they have a specific SPF for a specific type of the crash. And in our system, we have if you look at the right hand side, we have a window that you can store the information for your safety performance function, and these are also editable. So if you have a specific shape function that the shape or scale you want to modify, then this system can allow you to do that. And also one thing about the calibration, maybe if after 5-10 years you have to see if you need to change your safety performance function. So you have all the crash data, you can run some analysis, and Federal Highway have recommended each of the state to update their and calibrate the safety performance function. So maybe that is something you can also do. But the calibration process is not part of the SIMS project. It has to be using some other statistical tool outside of the system. So that is the second one, maintaining SPF. Then you run your screening, and while you're running the screening, basically we use SPF. We use some empirical based adjusted crash count, and then identify the level of service of safety. If you look at the graph below, this is the level of service of safety definitions. So basically, there is a median expected number of crash. You can see the light green, that is the median value, and you have the red one, which is the upper 80th percentile, and the green one, the lower 20th percentile. So it is dividing the zone into 4 different zones, level of service 1 through 4. So the hotspot rule is anything that is falling in level of service 4, we are identifying them as a hotspot location. So, and then the last thing in this process is identifying the benefit and cost. Getting the safety projects, and then do the benefit and cost analysis. and based on that, you can come up with your HSIP projects. Thanks. Okay. Now I'm just showing you, this is the end results of Montana's 2016 roadway departure analysis. So what you see on the right hand side is actually those zones that they have identified. And I have a number that they have, probably in my next slide, that they have roughly 415 hotspot identified. And what I did, I just wanted to identify them by the financial district. So if you look at this, the top 5 district, Billing, Butte, Glendive, Great Falls, and Missoula, you can see on the left-hand side, the graph, the bar actually showing you the total number of roadway departure crash. And on the right-hand side, which is the red line, is showing the length of roadway with level of service 4. So an interesting thing I found that in this hotspot analysis, I found the 2 hotspots that I was able to identify just using the crash data. So if you can look at the graph below, you can see those 2 hotspots that was visually I could identify by using the crash record, and by some structured method I can also able to identify. So that is like my first method of identification, which is by using crash record. Just simply the crash data is. It has been reinforced by using the structured way of identification. So you can always run different analysis and go back and see if how far your approximation was. The next item I would like to talk about the proactive measures of identification. So in this case, I would like to mention about 2 things here. One is the Meyer elements, and Montana has a roadway elements. They have started capturing some of the Meyer elements. I have highlighted those elements. Those are related to the roadway departure crash. For example, terrain type. Then we have median type, the shoulder width, median width. Those are all related to the roadway departure crash. So to some extent, they can contribute to the road departure crash. But the idea is this Meyer element needs to have more elements. Like, for example, the rumble strip inventory, the friction data, the type and presence of the clear zone, side slope, those information should also be part of that. So, and I talked to Tricia that they are going to capture those informations. So that is something we need to consider. The last 3 things that I mentioned here, the 3 things that is not part of the Montana system right now. This is something that we do not have for any US solution. That is like optimization, decision metrics. But we have done some similar implementation for Israel. So there is a roadmap for us to bring that into our core system. So we should be able to provide that information the proactive way. But Montana has a different tool. I'd like to mention the diagnosis tool, which is, if you have a Meyer element, you can easily run the diagnosis tool and identify if you have any issues with the roadway. I'd like to skip some of the slides. This is more like a proactive framework, like how we can identify different factors, and you can show it in a line diagram what are the different deficiencies on your roadway, and can come up with some kind of work plan for them. So this is just an example. My quick conclusion that analytic frameworks for using safety analysis is really helping Montana establish or confirm their goal and objective, and it also confirm their emphasis area and update the emphasis area, strategy, and HSIP projects. So it's helping a lot with all these different areas of improvement. And the crash data-driven analysis, which is very simple, but it requires some expert opinion. And I know that for safety engineers who have 20, 30 years of experience, they can run very nice crash filter to identify those. Network screening is a more structured industry standard for hotspot identification and project selection process. The proactive screening that Montana kindly have, it will need some update the data for the Meyer element. And we have 2 things on our roadmap for the proactive screening: the optimizations and the calibration of the SPF. It's not SPR. The calibration of the SPF that is in our roadmap. So once we have those features and next version, so we can benefit our customers using that. So with that, I would like to conclude my session. And do you have any questions for me or Tricia? The 2-lane undivided roadways you were referring to, is the statutory limit, is it 55 or 70?
70.
So even if the design
feet for that road is less, you'll not allowed to
It's-
establish a speed limit?
It's established by the legislature, and the only exception to that is a county can petition to our transportation committee that they would like it lowered, and then we do a speed study, but that is the only way that a speed limit can be lowered.
Is that a rigorous process, or is that something that the counties take up on a regular basis to try to do?
They occasionally do, I wouldn't say it's a regular basis, but we probably have 4 or 5 of them a year, but it's not something that, most of the time, the rural areas, they're happy with the 70 miles an hour, they would actually rather go faster. But it's not necessarily, from a safety standpoint, obviously that's not the thing to do.
Do you find that the studies y'all do perform is the 85th percentile generally around 70, or is it less than that?
I don't know on the rural 2 lanes. I do know we just raised our interstate speed limit to 80, and they did the 85th percentile, and it was running around 79, 80.
So it was
Right around this.
posted correctly.
Yes.
One more if anybody has one. Okay,